project here provided in CCS is already there, and if you want to know how to create a project, you can look into my earlier video which says how to install CCS and tivaware and create a project to just test an LED. So based on that, you can understand how a project is created here. And here we have certain library header files which is included, and then now we have a specific library which is EEPROM.h. Then we have two array, that is PU I32 data 2 and PI32 that is unsigned int 32 read size for AS2. Next we are going to give values to these arrays, that is just hexadecimal value which is of 32-bit size, that is 1 and then 2. Then system clock set to enable the system clock configuration for the for Tiva C. So which will give you around 50 megahertz, I believe. And then we have a delay, and we have another system clock peripheral enable, which is to provide the clocks for EEPROM. And then we have EEPROM initiate function. We will look into each function here. That is EEPROM init. That is if not called, it is like when we press the reset button. If this particular function is not called, it will lead to data loss, because this function checks for errors in EEPROM due to power failure during the previous write operations. So errors might be there when there was a write operation in the previous when we did a previous write operation. So based on this particular function checks when we click on the reset button. So with this, the function has to be included for sure. And then we have EEPROM mask erase. That this is going to erase EEPROM, and this will lead to a default condition where the memory will set to value 0xFFFF and FFFF. So again, next is our EEPROM read function. EEPROM read function is going to read the memory. So here we have the memory address, and this is the size which we are going to specify. It is like whether the number of bytes we are going to read is 4 bytes or 3 bytes, like that. So we have EEPROM program. Next we have EEPROM program, that is to write the data which we want to write. Like we have this data, that is 1 and 2, which are going to write into the EEPROM memory location starting with 0x00, that is the first memory location or the address. Then after that, what we are going to do is again read the same address to check whether the data is written. So this we are going to check, and let's build the code. Now the code is built. So click on run, debug. See to that your hardware is connected. And then we will have to add two variables to the watch expression. That is, after uploading the code, you have this window, that is variables expression and register. If you don't have that, you can go click view, then expression, and you will get this window where you will have to just click on add expression and type the variable which you are using here, that is PI32 read and PI32 data and PI32 read, which has been already written here. And then we will expand this, and we will add some breakpoints. That is, we will have a breakpoint here, and one more breakpoint is here, and we have another breakpoint here, and one more breakpoint here. So what happens now is, let's click on resume button and see what happens. So you can see it is this is actually the breakpoint stops here at EEPROM mask erase. When it crosses this, you can see you will have the data erase. That is the default condition which we discussed before. Next, the data is not written yet. This is the data which is given in array, and now we are going to read this after erasing. So we have now 0xFFFF in both the memory locations, and then we are going to write the data, that is the data which we have stored already, that is 01 and 02. Now after writing, let me pause this. You can see it has this PI32 is read from the EEPROM memory location from starting address 0x0. So this gives you value 0001 and 002, which was 0002, that is 1 and 2, which was not earlier available. And first we had FFFF, which is the default condition when we do the memory arrays. Then after that we are writing the data into the memory location and reading it. This is what is happening. So this is how EEPROM works, and we can use this API library to read and write EEPROM. And there are more lots of things to learn, and you can further proceed with your data sheet, which is also available in TA website. Thanks a lot. We'll meet in another video.